So this is problem from chapter 15, number 23. This problem says a horizontal wire is stretched with a tension of 94 newtons. Let's write those down as we're going. Tension equals 94 newtons. Tension of 94 newtons, and the speed of the transverse waves for the wire is 406 meters per second. That's our velocity. All right, so it says 406 meters per second. What must the amplitude of the traveling wave of frequency 69 hertz be for the average power carried by the wave to be 0.365 watts? So let's write these down. So our frequency equals 69 hertz. And the power is going to be 0.365 watts. Okay, awesome. So, we know the average power carried by a wave is given by the equation P equals 1/2 the mass per unit length times the amplitude squared times the rotational speed squared times the velocity. Okay, as well as we know the equations, velocity equals the square root tension force over the mass per unit length, and then the rotational speed is equal to 2 pi times that frequency. Okay, so by substituting these, so let's change this one up a bit. So it's the mass per unit length is equal to T over the velocity squared. Let's change that up. So by substituting the values of the mass per unit length and the rotational speed, the formula to get power, we get power is equal to 1/2. That's going to be tension times the amplitude squared. That's kind of small. You're right, it's a little bigger. Tension times the amplitude squared. Actually, that 2 goes on the bottom. Tension times the amplitude squared. It's 4 pi squared. 2, the squared actually goes inside the parentheses, my mistake. Sorry. 4 pi squared, and then the frequency squared, all over 2 times the velocity. Okay, so the amplitude is equal to the square root. It's a really bad square root of the power times the velocity over 2 pi squared times the frequency squared times the tension. Okay, so we plug in all of those values. So we have the 0.365 watts times our velocity, 406 meters per second, over 2 pi squared, frequency 69.0 hertz, and then times our tension force, which is going to be 94 newtons. After solving all of that, amplitude is equal to 0.0041 meters.